Okay, now we're going to do operation 2. So let's hide this instance of the device, show the next one. It helps with visualization. And again, for this operation, we can keep our origin on the machine in the same place if we set our origin on the bottom left corner. We don't have the stock. We will need to use the stock model for the first routine, but before we turn it back on, we need to set our origin and do our setup, which is going to be based off machined edges. Okay, to set our origin for these other operations, because we have this chamfer, we don't have a selection point. So Fusion gives you some canned options which works, like the stock box points and the model box points. But we actually want to clamp onto this edge that, even if we go off model box point, is basing it off a corner that's out here because that's the extents of the model. In this case, we want our origin to be placed on the fixturing in the corner. And what we have is a chamfer here that won't allow us to select that corner. We can do selection, but we need to create something that we can pick on there. So what we can do is we can go back to our model. If you made this model roughly how I did, this was based off a sketch and the chamfer was added later. So if I go to my first sketch, it has that intersection. So I'm going to make the sketch visible, and just temporarily. And then if I pick out in space, you can see this purple edge is the corner I want. In another operation, we're going to want this corner. Okay, so we'll leave that visible for now. It'll give us some pick points. Setup, we're going to create a new setup. And we're going to start with our orientation. So the orientation is not going to be model origin. We're going to do z-axis and x-plane. So we pick on the top of the model for our z-axis. Our x direction is going to be along the edge of the stock there. We don't want to change this until we've selected what is our model. So we need to hit select and pick on our model body. And this will allow us to change the selection mode to a selected point. And we're going to make the stock temporarily invisible. And then you're going to pick our location, which is going to be, right now mine happens to be snapping to the right spot, but we're going to pick on that corner that is that intersection that's on our sketch. Okay, and so that's where my origin is. Okay, it happens to correspond where my model origin is, and so it may not appear like yours if you happen to put your origin on a different corner than I did. Okay, now we're going to go to stock, and we're going to go ahead and use from previous operation. And then we're going to go to post-process. We're going to call this 7310-2. Okay, it's the second program. We're going to call this op2. And we're going to use WCS1. That's it, okay. And we're going to rename the setup op2. Now we're going to turn our stock back on temporarily. And we're going to use the same face mill we used in the first op. So let's highlight the face mill. You're going to use Control-C, or you can right click on it and say copy. We're going to pick operation 2. We're going to do a paste. The folder's closed, so once we expand it, you should be able to see the face mill. We're going to left click on it, and we're going to right click on it. We're going to edit, and we're going to use the same tool, feeds and speeds. Under geometry, it's going to select the opposite side of the part. Under heights tab, we're going to go stock top. The stock top is fine. We're going to go, we don't want to go exactly to model top. That will skim right on this arc, and since the top is not flat, we want to leave actually some material there. So we're going to leave 0.04 material. That's about a millimeter, which is what I was calculating there. So it's going to leave a millimeter for our finishing cutter to machine down. when it does the surface cutting at the crest. Okay, and then we're going to go to passes. I don't think we need to pick a pass direction. You could, it'd be, the length of the part. And what we do need to change is we're going to come down here and pick multiple depths, and we're going to do 40,000 steps. What do you know? That's about a millimeter. And we're going to come in from both sides, because that's not a finished surface anyway. And then we'll use even step downs. We could have used stock to leave instead of setting the height values, but that's okay. We're going to leave it the way it is. We go to the linking tab. We're going to keep all this at default, and we'll hit OK. Okay, so that's our first cut. We've decked the material down to close to the top of the part, leaving 40 thousandths at the top. We've cut pretty much all the way around the perimeter on this thing already, and we've milled down most of the material. So our perimeter is pretty close to this, only the top is flat. Now we're going to do our 3D moves to machine this surface here. So there's a variety of different commands you can use, and I'm going to use the parallel command, which is parallel to a side. Okay, so we're going to pick parallel. We're going to use the 1/2 inch ball. The larger the diameter of the ball cutter, the smaller the scallops, or the flatter the scallops are, so in theory you get a better finish. So we're going to go to the aluminum library. We're going to use the 1/2 inch ball cutter, and we're going to hit select. We're going to do a rough cut first, leaving some material, and then we'll come back and do a finish cut. That way we have a consistent load on the cutter at any given time. So what we're going to do is we're going to go leave this all at default, and we're going to go to geometry, and we're going to try to leave the boundary on silhouette. Our tool containment is going to be, we want the cutter to go to the center of the boundary in this case. No additional offset. Okay, contact only with the boundary. We're going to turn on slope. It's going to cut anything from 0 to 90 degrees. Rest machining we'll leave alone. And the model surfaces we want to cut. We just want to cut this one surface. Okay, I believe we leave the rest of this at default. We're going to go to the heights tab. We'll just leave these at stock top. That's fine. A selection point, which is the lowest point of the surface we're cutting. And then we're going to subtract half the diameter of our ball cutter. So negative 0.25. So it'll allow it to roll past tangency if it needs to. Okay, then we're going to go to passes. And I'm going to actually set a pass direction as one of the edge lines. We're going to go in both directions, and we're not going to do multiple depths. We're going to do stock to leave on this first one. We're going to leave 40 thousandths, not 4 thousandths. And we're going to turn on the smoothing deviation. Let's do 60 thousandths, not 600. And then we're going to go to the linking tab. We're going to leave all this at default. And we can leave the vertical lead-in radiuses on in this instance. That should help. Okay, we're going to hit OK. And we get our cuts that are going to start at one end and go across the other. So what we need to watch is here where it dives. Now we're going to copy that routine. We're going to use a duplicate, and we're going to modify it to do our finish cut. Okay, at this point we want to go fast. We've removed most of the material. We want to fine finish. Okay, so we're going to bump our RPM up to 5,000, and then our cutting feed, we're going to increase that to 50 inches a minute, And then our ramp rate feed rate, and our plunge rate on a surface cut is actually sideways, except for the very first move. So we're going to go 50. We're going to go 50 inches a minute on 50 minutes a minute on that one. Now, it's really important that you remember, if you do a routine after this, to slow it back down to the defaults for other things. Okay, let's go to heights. We're cutting to the model surface. This all is going to stay the same. I don't remember setting an additional offset. We're going to set that at 0. We're going to go to heights. We're going to leave all this at default. We'll leave this selection the same on this one. Technically the lowest the cutter can go is that blue plane. Probably won't go to it anyway. We're going to go to passes. This is where we're going to change our step over to be 10,000ths. And we're not going to leave any stock in this instance. We'll leave our smoothing on. Go to the linking tab. We can leave the vertical lead in, that's fine for this. And we'll hit OK. So we get a fairly fine step over. It's moving pretty quick. According to my time calculation, that run routine is 12 minutes. So, but it should give us a pretty good surface finish. Okay, so now we're going to do the text. So we need to go and make a sketch visible. Second to last sketch in our model, if you project it the way I did it. Okay, so it shows up as magenta, pink, whatever you want to call that, letters. Okay, what we're going to do is we're going to do what's called a trace command. So we're going to go to 2D trace, and it actually follows a 3D shape. And with the smallest cutter we have, ball cutter is an 1/8 inch in the library, which is not ideal. It'd be nice to do this with a much smaller tool or an engraving tool. We're trying to go away from using the chamfer mills, and the ball cutter will give you a better, cleaner result with less burrs. The drawing says to go 20,000 deep. That's too deep. That's an error on my part. Apologize for that. We are going to just skim the surface, and then due to how light we need to go to have this text show up, we're going to just adjust that at the machine till it's barely cutting in the surface. So I'm going to actually have you program this so that the text is right on the surface, and chances are there's going to be enough variance between the cutters that you may get it engraved just fine with that, or you may need to adjust this cutter down at the machine, and that's a reason to have this as the last routine as well, so we can restart it. Okay, so we're going to go 8,000 RPM. I think we'll just leave the feeds and speeds as they are. We're going to go to geometry, and we're going to select our text. So we're going to go to the top view. We're actually going to see if we can pick the entire sketch. To expand the sketches, we're going to highlight the sketch. We should get all the geometry within it. Remember, your text has to be exploded, so if you didn't explode the text when you made it, make sure you've done so. So this makes it easy if it's clean and it's the only thing in the file. And then we're going to go to Heights tab. We can go ahead and leave this stuff at default. On the Passes tab, we're going to leave all this at default. Let's check the smoothing box. We could put an axial offset here. This would be a negative number. So you could put -1,000th. But I would rather have you come out with the lettering too light on the first pass and do some adjustments in the machine than have this not come out nice. So again, apologize. We're going to work in better tooling in the future for this. We're going to go to the linking tab, and we don't want to lead ins and lead outs. We'll just gouge our part on this type of thing. You can set a preferred lead in position, but I'm going to just hit OK and see what we get. Okay, so we get centerline toolpath. It should be three-dimensional. Even though it's a 2D command, it follows the curvature of the surface. And that should be pretty much it. Okay, we're going to go and move on to our next operation. Okay, operation 3. Go ahead and hide the sketch for the engraving since we're done with that. We're going to move on and hide the current vise setup and move on to operation 4's vise setup. Okay, again, this is a shorter parallel, so you need to keep track of this when you run it. The 1 5/8 are the tallest we have. There's one set at each machine. The other parallels are in a set that you in a red box, and you'll have to ask for them. We're going to kind of keep control of that so we can double check your work. And so we should be using the 1 1/8 parallels. The main thing is that this the crest of this arc is on the rear vice jaw. Okay, we're going to do our new setup. So we're going to go new setup, and we're going to go to stock, and we're not going to base it off the previous. We're going to go off solid, and we're going to select the part, because there isn't any stock left on the exterior. It's the part minus these holes here. And we're going to go back to the setup tab, and the model is also going to be the body of the part itself. So in this sense, they're kind of one and the same. Okay, now we're going to set our orientation. We don't want it where it is right there. We're going to go Z-axis plane and X-axis. We're going to pick on the top of the part, set Z, and we're going to set X as the horizontal line on the part. And then we're going to go to a selection point. We're not going to use a box point. And we're going to pick on this corner of this sketch that we have. And that'll put it down on the bottom of the parallel. So that way we don't have to change the height when we flip this over for the the next operation. We use the bottom. Alright, so we got that covered. We're going to go to post-process. We're going to call this the 7310 op3, so that's going to be 3. Program comment op3, work coordinate system 1. We're going to hit OK. That should set our new setup. We're going to change the setup name to op3. Be consistent. And what we're going to do here is we're going to machine these holes, okay? And I do believe we have a 1/2 inch drill bit in our library, and if we check this hole diameter, it is 547 thousandths, so it's bigger than a 1/2 inch. So there's a couple approaches we could take. We could just circle and interpolate these, don't worry about a drill bit, and pocket them, and then the other approach is we rough them with a 1/2 inch drill bit, and then we come back and do a contour with a smaller cutter. Drill bits are the most efficient way to remove material for this type of operation. So we're going to go ahead and drill it first, and then we're going to come back and open the holes up. We're going to drill each one. We're going to spot drill each of these locations. We're going to drill each one of these locations. We're going to profile the inside of the hole, and then we're going to use a chamfer mill to do the chamfer on the edges. Okay, so we're going to go to op3, and we're going to do a drilling. And we're going to select for milling tools, the 3H chamfer mill, and we're going to select that. Now this cutter is too small in diameter to make this chamfer as a spot drill. If we had a larger diameter spot drill, you could. We're just trying to give something for the 1/2 inch drill bit to center on so that we get a more accurate location. So we're going to go to geometry and let's just select each hole feature. Okay, and we're going to leave all this at default. We're going to go to height, and this is where we need to play with it because we don't want to drill the full depth of this hole here like that. That's too much with this cutter. So what we're going to do is we're going to go from stock top and model top is kind of semantics on this. What we could do is we could select this plane because it's basing those off the highest point on the part. It's safer to just leave it as is. We're just going to retract a little bit more. But if this was deep down in a pocket, you might lower it down to another feature. So we'll just leave it at stock top. We're going to start our machining feeding at hole top, but we're not going to go down to hole bottom. What we're going to do is we're going to base this off hole top, and then we're going to put a negative value in how deep we want to go. So we just need a dimple that's big enough for the very tip flute, the very tip of the drill bit. It's probably not very much. So let's go 0.06 deep, 625, and that'll give us an 1/8 inch diameter spot on the surface. We're not really cutting very much. And I'm sorry, that should be a negative 0.0625. And this actually should have been hole top. I'm sorry, that's why I'm looking a little confused. So we're basing it off hole top, and we're going to go 1/16 deep, and we should get a little peck cone there. Okay, since we're not intending to make a specific chamfer with it, we just need a little lead in. Okay, we're going to go to cycle, and for this we're just going to do a drill and wrap it out because it's about what 1 peck would be with that cutter, so there's no need to do a deep drill cycle. And on our linking tab we'll leave this all at default. Is that okay? Alright, so we got our little dimple cuts.